Alrighty, question 12a. A curve has equation y equals 6x root x add 32 over x for x greater than 0, and we want to find dy by dx. So, first of all, write the equation in power form. So we got y equals 6x times x to the power of a half, add 32x to the minus 1. Now, 6x x to the half, well, x is x to the power 1. When we multiply by x to the power of a half, we add the indices, so we get 6x to the 3 halves, add 32x to the minus 1. Okay, so now we're ready to differentiate. So dy by dx. Okay, so the power of 3 halves comes down and multiplies the 6. So we get 3 halves times 6x. And the power goes down by 1. So that's going to go down to 1 half. So that's that term. And then 32x to the minus 1. Well, the minus 1 comes down. So that gives us minus 32x to the minus 2. So 3 halves times 6 is 18 over 2. So that's going to give us 9 root x minus 32 over x squared. Cool. Okay, now for part B, we got a nice 5 marker. So, we are told the point A lies on the curve and has x coordinate 4. We want to find the coordinates of the point where the tangent to the curve at point A crosses the x-axis. So, quite a big question. Let's think about this. What we are going to need to do is work out the equation of the tangent. When we have the equation of the tangent, we know on the x-axis y is equal to 0. So we can set the equation of our tangent equal to 0 and solve for x. So we're going to need 2 things to be able to find the equation of our tangent. We are going to need the gradient of the curve at point A, and we are also going to need the y coordinate at A. So let's first of all find the y coordinate. So we do that by substituting x equals 4 into the original equation, which was 6x root x add 32 over x. So when x is 4, y is 6 times 4 times root 4, so times 2, add 32 over 4. So 6 times 4 is 24, times 2 is 48. 32 over 4 is 8. So our y coordinate is 56. So at this point, we now know the coordinates of A are 4, 56. Okay, so next we can also work out the gradient of the curve at point A by using our derivative up above. So the gradient at A is dy by dx when x is equal to 4. So we're substituting x equals 4 into our derivative. Now our derivative was 9 root x minus 32 over x squared. So that's 9 times 2 minus 32 over 16. So 9 times 2 is 18, 32 over 16 is 2, so we got 18 minus 2, which is 16. Okay, so now we can start to find the equation of our tangent. So the equation of the tangent, it's a straight line, so it's of the form y equals mx plus c. Now we know m is our gradient, which is 16. So y is equal to 16x add c. Now to find the value of c, this is why we needed to find the y coordinate of point A. We now substitute the coordinates in. So our coordinates are 4, 56. So when x is equal to 4 and y is equal to 56, we get 56 is equal to 16 times 4, which is 64. Add c. Therefore, c is 56 minus 64, which is minus 8. So, up to this point, we can now say our tangent is y equals 16x minus 8. Okay, so finally, what we want are the coordinates where the tangent crosses the x-axis. Now, on the x-axis, y is equal to 0. So, we get 0 is equal to 16x minus 8. So 8 is equal to 16x. So divide by 16, we get 1/2 is x. So the coordinates are 1/2, 0. Good times.